expectation.
Yeah, I like it. That's good. Good. Well, it's the 6th of August, 2024. I know where I was um, 9 years ago today because my niece is turning 9 today. So
Awesome.
happy birthday, kid.
Oh, that's awesome.
Yeah, and this is PPBL Live Coding. We get together. Well, it's hard to say exactly what days we get together because our schedule is in flux, but you can look at gimbalabs.com/calendar to look at upcoming events and to find registration links for events like this one. But we're about to jump into a lesson, and we thought before we did, we could do a quick check-in round. We got Alex, Harsha, Newman, and me here today. Alex, how you doing?
This is the first live check-in that I've seen at Gimbalabs.
That's true. We broke with tradition.
Yeah,
Oh, we
seriously?
started the live stream. Oh, yeah, right.
Oh, wow.
Hey, YouTube. Hey, YouTube.
I'm gonna get
Sometimes
famous.
this happens.
Yeah, I'm doing really well. Actually, uh, thinking about some stuff lately. And yeah, in particular, I was thinking about writing a Gimbalabs proposal to look at a certain thing, but then I thought like, maybe I will show up in a couple of live codings and see if there's some room for discussion. I just could talk it without writing, So, but otherwise, yeah, thinking about Cardano a lot, and in particular about the Haskell part and uh, but not building smart contracts, which is interesting. Yeah, that's for me.
And hey, man, congrats on the work at Intersect. It's so exciting to
Thanks a
hear
lot.
that.
Yeah, that's really kind of. I'm speechless.
That's a really big deal. That's really
Yeah, but
cool.
really happy.
And Harsha, how you checking in today?
I'm doing pretty good. Yeah, I'm just excited to like get through this module and see uh if we can get something interesting for the video.
Sir,
Yeah.
thank you. Newman, how are you?
I am great. Just two things. One, coming off of the big stadium concert at Citi Field last night with the Linda Linda's really great sort of new band, Rancid,
Whoa.
the punk band from the 90s that are still making music. Smashing Pumpkins, which was really phenomenal, close to stealing the show from Billy Joe Armstrong and his crew at Green Day, but they ripped through two albums solid. It was like a giant, super long concert and uh, really, really incredible to see 35,000 people just screaming their faces off.
The whole,
And just
like, people
getting,
must have been singing along the whole time.
oh yeah, the whole time. It was a, yeah. And he's like a real rock star. Like that, it is a thing. It's Mick Jagger, Freddie Mercury, they're doing the same stuff. It's
Yeah,
just it's pretty amazing to see. And
that's
um and then the other thing, which is, maybe slightly more relevant, I'm really stoked about the PBL and getting, the old tutorial chops going. And so I'm really excited about this next hour and some that we've got, planned with each other.
here, here. And Sebastian snuck in. Maestro, how are
Hey
you?
guys, pretty good. Really nice being here. Pretty good. It's a study.
Thanks. Well, I didn't see Green Day last night, but that sounds awesome. I'm feeling good. Yeah, excited. It feels like we're doing something new here. And I'm excited to find out what it is together. So we had a few starts to this lesson last week, but we were already learning and we were kind of turning the lens back on ourselves last Wednesday, just thinking about, okay, like what is the pathway through this lesson? And then I threw a wrench in things by giving Harsha the wrong uh a poorly punctuated command, but we're going to try this again today. And we talked offline about doing all of the lesson here in Demeter. So it looks like you've already got the Demeter console up.
Yeah. And I have the 3 repos here.
Perfect. And just for context, can you just jump back to that lesson for a second so we can kind of see the
Yes.
learning target? Right?
Yes, learning
just
target.
It's right there at the top, at the very top. 203.
I can right here. I can mint an NFT that compiles with CIP68 standard.
So we're going to explore those concepts today. Okay, and Harshi, you mentioned you've got the 3 repos. We're also pulling together a lot of what's already happened in this course, from early on, just setting up Aiken, to the previous lesson where we minted an NFT according to the CIP25 standard. And now we're ready to jump in and play with some ideas here. And that's what's really exciting, is that we are going to be touching on various background knowledge.
So I did mint like a test token. Where's that? I just minted this 222 module. So the 100 token should be in the contract address, I think.
Yeah, cool. And did you do that from the front end?
I did that from the example front end on Plutus, like right here.
Right on.
Right here.
Yeah. So this is a live demo that we're going to look at the source code for. And so you're looking at it deployed at PlutusPBL.io right now, where anybody can go mint one of these tokens and then play around with it. And what we're going to do is step by step go through the components that were used to build what's on the screen right here. But Harsha, if you scroll down, looks like your wallet's connected. We have this little gallery right here, 203.4 gallery. And did you minted the EX002 one?
No, I don't think so.
No, I just called it module test.
I don't think you did the
I don't think I put like a image on
in.
it. Did I?
Yes.
No, there's no image.
Let's look at the transaction. This is a good place for us to start. You can look at the transactions tab of your Eternal wallet. And there's the one where that was minted. So if you just click to expand, and let's go look at that transaction ID.
I love doing this, FYI.
Yeah, I love it too. And let's look at the UTXOs. So these are the ordered inputs and outputs, in case you're wondering, right? This has a transaction hash that's at the top of the screen. And then these 3 outputs are the indexes 0, 1, and 2 in order. Okay, that's just a nice convenience. Then we've got the 100 module test token was sent over to this contract address. That's great. And we've got that little datum circle at the end of the contract address.
Oh.
Okay, let's go inspect that. So everyone by default is given this datum right here. Okay, and that first byte string, field 0, is a hex string that we can decode. So if you've seen like the hex to string website before, or by any other method, let's decode this to see what it is. Okay.
Gimbalabs.com g.png. So it's the Gimbalabs, this one.
Just a default image.
This one?
Yep, just a G. So that
Okay.
one must be yours.
Oh.
Okay, so the second component on the example page.
Second component, update reference token datum.
Yeah, you can put a new image URL in the first form field, and you can change the description as long as you're the owner of the 222 token. And that's why these other two images here are no longer just Gs.
How would I access this link for the image?
There's a few ways. One, we could query the address and you could look at the datum, right? We just looked at the datum for your transaction, but let's do a little bit of playing on Cardano scan for just a second, right?
Okay, perfect.
So this, and the other tab, this is the datum. But notice that we've got like this contract address right here, 3A3. Click on that address. And this is going to hold three assets. There's three images, right?
Mm-hmm.
So click the tokens balance drop-down menu.
Tokens
Down.
balance drop. Oh, right here.
No, down.
Oh,
farther.
this one.
Yeah, that
Okay.
one. Yeah.
And so I see you've got the module test one, but let's go check out first example. Yeah, look at that one. And let's look at the most recent transaction for this token, the one at the top of the list.
This one?
Yep. And then once again, look at the UTXOs. Now, what's interesting, this one had an input UTXO from this address, and that's the default datum that was actually replaced in this transaction. You could look at it and it would look just like the datum for your token. Which you still have open in the next tab, so you could just compare these, right? We have 6A7474 HTT, right? And so
Yeah.
that string right there, that's the default string. But in
Correct.
the transaction that we were just looking at, the output has different datum.
Okay. Yeah.
It's the same structure. Oh, that's a longer string. Okay. And let's decode that one.
Andamio logo. Okay.
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 So that's where that image that's on the PPBL front end is coming from.
Oh, got it. Got it. Okay.
Now, it's worth noting, a lot of the times when people think about Web3 NFTs, they expect to have some kind of perma storage for the image, right? Whether that's IPFS or Arweave or some other option. We're not worrying about that part here. And it's fine, right? What this is to show that in both SIP25, SIP68, or anything else we might do with images, there's nothing stopping us from using an old-fashioned Web2 URL like this one, okay? But I could just as well drop an IPFS content ID in here, and it would say IPFS : / and then the content ID. And that's how a lot of Cardano NFTs are built. For the purpose of this assignment, yeah, if you have a link anywhere, or you could just, you could find one like even just open source Wikipedia kind of style image, you can just do it to show that it works with that form. And then the image, your just a G would change to whatever image you change it to in the gallery.
So directly use this new URL here.
Yeah. Let's do it. Do a different one. No, not that one. Same one. Do a different one. Come on, man.
This is the different one.
Oh, it is? Oh, okay.
Well, no, that's the one that's being used down below. But why don't you use andamio.png if you're looking for a quick image? We have one there.
Oh, yeah. Just at the
Andamio.png. So
Yeah.
just replace this with PNG?
Yeah, get rid of
or-
everything after the andamio and replace it. Just .png. And you can go to this URL in a browser. It's just where we keep the higher res logo. And then
Okay,
make a new
okay.
description as well, right? Just maybe
So
say-
when I'm changing the description, what exactly is changing in my token?
Oh,
the
yeah, good
second
question.
datum field. Go back to one of those, the datum we were looking at,
Oh, okay.
any of those
Uh,
inspectors. The
So this
URL
is
is that first string,
correct.
and the
That thing
second
right there.
string is the message. Yeah, so
Oh, I
it
see. I
goes
see.
that way.
Let me quickly check what this says.
Right,
EX. Oh,
right.
so it's just okay. Got
So
it.
that's the caption on the leftmost image in the
Nice.
gallery.
Oh, I see. Um, oh, I see. I see. Okay. Okay. So we can say anything for the description, like
Yep.
Come on. Wait, what?
Oh,
Please.
that's not the right. Let's see. Well, okay, so first of all, that's because the text wasn't changed on the alert for this button. Clearly, we're not talking about entering an alias, but do one thing. Is your wallet hooked up correctly?
yeah.
I'm assuming it is. Yeah.
How would we find out? Oh, yeah,
Just
there it is.
just
Yeah.
check in Eternal that the plugin thing. Yeah, it's plugged in. And then go refresh the page. This should work.
Refresh which page? This one?
This one, yeah, and then connect again. I'm not sure why that happened.
The image, and let me.
Oh, you got to change the URL though.
Yeah,
Also.
yeah.
Oh, okay.
So let me get this guy.
That's brilliant, man.
I have so many tabs I keep.
You're doing great.
It's marvelously navigated.
Yeah.
All right, let's see.
Okay, no,
That's
right.
better.
So it's just
Yeah, okay.
refreshing. Okay.
This demo page is not properly productionized. So what happened is you minted the token in the first component, and ideally in an application, you wouldn't need to refresh the page for that to work. But at the moment, that's the case. That's a fun advanced thing for us to fix a little down the road.
Okay. Okay.
All right. So
You can look at your transactions tab and we'll see the status of this one.
this is pending.
And all it is, you're only really paying a fee and you're just sending a little ADA to yourself. Other than that, not too much happening here.
So in general, when I look at this, how come like image is not displayed in this?
That's the question. That's a perfect question. Okay.
Nice.
It's because where Eternal doesn't implement SIP68 the way we are using it.
Oh,
Okay. So it's actually the only reason that these pictures do show up for the ones where you can see them is because the developers of this wallet implemented SIP25 in the wallet. There's nothing inherent about how the blockchain works that a tool you build with it is going to have that functionality, right? You as the builder have to build a tool. Now there's a blueprint for building that tool. It's called SIP25, and it shows you exactly how the data should be structured and where to find it on chain. But you still have to implement it in the software you're building. And so anywhere whether it's Eternal or Nami Wallet, JPEG Store or Pool PM or anywhere else that you can look at a Cardano NFT, right? All of those places exist because somebody implemented SIP25 in the application.
Got it. Got it.
And so it's thrilling, right, that we can't see those here, but could you imagine that it could be implemented if we wanted to? And the example of the implementation is in our image gallery on the course website. Changed image.
Hey, it worked.
Yeah, this transaction went through. I will check this on so we have the transaction.
That one's the input, so that's the old data.
Oh, these are the inputs. Okay.
Yeah,
So
decode that.
I have the
Decode the second string right there.
Should be, yeah.
changed image, I
Yeah,
think.
right, yeah.
And if you spend enough time with it, you start to be able to read the hex itself.
Oh man.
HTTP, for example, right? Those four letters over and over again.
Yeah, yeah. Oh, is that a hex? Does that convert somewhere to hex? Oh my God. What is, type
This
in
is the hex, no?
HTTP.
No, the
Oh, I'm just-
HTTP would be this one, I think. The other one. This
But yeah,
one
if
should
you
have
look at
HTTP.
68747470, right?
Oh, that's HTTP.
74 must be a T, right? So 68 must be an H.
Oh my God, you're
H
right.
is 6 letters before T in the alphabet, apparently.
Oh my God. Oh my God. It's all like starting to, that's wild.
Yeah.
Brilliant, man. That's awesome.
Yeah.
Interesting. Okay, our brains are changing.
Got it. So basically the front end, this part is changing like the image URL, and this part is changing like this below part, the
Correct.
bytes, this part. Okay.
Now, this is at the crux of what we're doing. This datum right here is not at all formatted to what SIP68 suggests, okay?
Mhm.
But what we are going to do today is see how this token pair works together to enable the functionality that we just looked at, okay?
Mhm.
Then in the assignment that follows this lesson, there's 3 levels of challenge, okay? So yeah, you can actually skip ahead to the next, if you scroll to the bottom and then click on the assignment button. Right, we lay out some important stuff, neat stuff, and tough stuff that you could do, okay?
Can mint an asset. Okay.
Right, so these are the learning targets. We hope that at the end of this module, you can think about these 3 things. And when it comes to important stuff, we want you to make sure that you can build a transaction with metadata, for example. So that's the first thing you'll see as you start scrolling into the options.
Yeah, important, neat, and tough. Yeah.
Use CLI optionally with shell script. Use mesh. So when we are using the example, are we using mesh?
You're going to see how to build the transaction that we just did in Mesh today. Yes.
Yeah. Yeah, that's the lesson. Because so we just did the example, the front end, and now we're gonna rebuild that with the React in Mesh. How will we use the Game Changer wallet?
Well, this is a different task. Look, the
Oh,
important
this is a
stuff
different.
here.
Oh, right.
Build, sign, and submit a transaction that posts a message to a metadata key. This would be a puzzle that for you to figure out after having been through the lessons. And you're actually not exactly doing the same things we did. But this is really an assessment of learning target 203.2. If you can mint an NFT according to SIP25, right? Then you should also be able to extend that knowledge into putting some other metadata on chain. And so this assignment is a challenge to do that.
Right.
But Harsha, the reason I brought this up, sorry, is at the bottom, the tough stuff is the real challenge assignment here. Okay. Use the pattern that we're looking at in lesson 203.3 to fully actually implement SIP 68. And if we have time, we can come back around to this, or this is something that we can look at together at live coding sessions anytime. But it's here in the course for anybody who wants a pretty interesting challenge just to run with.
Cool.
Now, the reason I'm showing you that is because we have not fully implemented SIP 68. And that's another reason. I actually don't know whether Eternal implements it in terms of showing those images in the wallet, and we should find out. But I wouldn't expect our images to show up because we're not following the standard fully.
Mm.
All right. So with this context, let's start going step by step through the lesson.
Love it.
So when we were going through the lesson, we had a question here. What does it mean that metadata cannot be changed, only replaced?
All right. So for any SIP25 NFT, right? Think Space Buds and anything in that era, people are still making them. The metadata that says what image is associated with the token in your wallet, that metadata is actually in a transaction. And this is kind of a funny thing to wrap our heads around, okay? Because what we just saw, this example, the metadata with the andamio.png link, for example, and the changed info or whatever we wrote right there, changed info, all of that datum is actually in the same UTXO as a token, right?
Mm-hmm.
But metadata is not like that. Metadata is on the transaction outside of the UTXOs. Okay. And so one way to think about this, right? People like to compare UTXO to cash, right? So I have a $10 bill, a $20 bill, and I hand them to the clerk at the store. I get some change, right? Those are my output UTXOs, and the store keeps some of the money. Okay, fine. But I can also get a receipt, right? Printed out that says, here's what you purchased. That receipt is not my money. It's an element of my transaction, but it's separate from the money itself.
Oh, okay.
What we're doing with Datum is almost like writing the data directly on your cash, right? If you find
Okay.
this, if you find this $20 bill, call this number, right?
Right.
So where? Oh, go ahead, Newman.
Well, just to wrap up that analogy, in this analogy, so yeah, I spend 20, I get a 10, a 5, and some change. I get the item that I bought, and then I get this receipt. In SIP 25, the like receipt data is actually written on the cache. That's the UTXO.
No, in SIP 25, the metadata is written on the receipt, not on the cache.
Okay.
Yeah.
Okay. And then in SIP 68, it actually goes with the transaction.
In
The
SIP 68,
UTXO.
it's actually in the UTXO itself.
Okay.
With the value, with the token.
Yeah.
So when you say a receipt, where is the receipt stored? Is it stored on the blockchain or?
It is, yeah. So the what's on the blockchain, right? When we talk about this blockchain having run for the last few years, right? What's on it? Transactions. That's all. So you've got, right, the whole blockchain is a list of blocks. Every block has transactions in it. Every one of those transactions is a record of outputs from previous transactions being spent and new outputs being created. Those are our UTXOs. If we look at all of the UTXOs in existence right now, we see the current state of the blockchain, right? We know that all these transactions historically have happened, and at this moment, here's all the outputs of all of those transactions. UTXOs are the most important part of a transaction, right? What were the inputs and what were the outputs? But there's other stuff in a transaction. There's a timestamp on it. There's a block, right? Every transaction must have been included in a single block. You can scroll to the top of this page to see, right? So, right, this transaction has a hash. It was in a block at a given timestamp, for example, right?
Yeah.
And then down below is a lot of details, right? Okay, what are the UTXOs? That's really important. And there's some optional stuff. Maybe it was related to a contract. Maybe there were collateral UTXOs. Maybe there were reference inputs. And there's no great examples of this right here. But head over to your Eternal wallet again and choose any of your tokens. If you go to your account tab, pick any of those tokens that does have an image.
Oh.
Right. And copy that policy ID and drop that into Cardano scan. Okay. Now go to your 222 G0 token.
Oh,
Right. And let's find the minting transaction for this one. And let's take a look at that most recent transaction. That's fine. Now, if we look at the tabs down below, this one has a lot of the ones in common. It's got UTXOs, contracts, collateral. This one also has metadata. Let's look at the metadata. And you can click on that to see it in a more friendly way.
Click on
The
this
JSON,
one?
yeah.
Okay.
Yeah. This is the receipt. This is metadata. Okay. It's on the blockchain and it's in a transaction. Now, it is inherently linked to the token in question because in the transaction where that token was minted, this metadata was included, okay? But to solidify that connection or to make it possible to mint many tokens with lots of different metadata in a single transaction, we still have to include a lot of information right here. We have to include the policy ID, 992C, right? And then we have to include the name of each token we mint under that policy ID. In this case, it was two different tokens, the 101 and the 222. Now, that seems like a lot of information to put on a receipt if all of this information is already in the blockchain. That policy ID, right? Isn't that policy ID already on chain?
Is this the policy ID?
Yeah.
Okay. Yeah, yes. Yeah.
And these token names are already on chain, but we have to include both of those in the metadata as well, because that's what's going to be pointed to when we want to look up the images that are associated with these tokens. And it's kind of a lot of work once you think about it. So this can't be changed. This receipt is on a transaction that's in a block that's immutable.
Mhm.
right? But it can be updated. And the way it can be updated is suggested in SIP 25. So if you have the SIPs pages open or just want to link out to it, let's take a very quick look at SIP 25. And scroll, I think, all the way to the bottom. Up a little bit. Update. Yeah, here we go.
Okay. There's that 721, which is basically, it's just like a little, hey, we're using this format of the JSON.
Right. So same format, but notice that last sentence of the first paragraph is really important too.
Okay, so that's a parameter. This is only possible if the policy allows to mint or burn the same token again. Ah, that's sort of that fungible, semi-fungible, non-fungible.
Right. So in
area.
other words, actually for any NFT that has a closed minting policy with a deadline that's passed already,
Then it's this is
you can't
then,
change the image.
yeah, yeah.
Mhm.
And in many cases, that's actually what you want. We want a guarantee that this thing is what we said it is, whether it's an image or any other sort of attestation, right?
Yeah, kind of the traditional why we think of an NFT as important and valuable because of this not the immutability of it. You can't change it, can't update it.
But so that the image is being accessed from IPFS or something like that. If we remove that image from IPFS, then it won't be able to access it. That means we have changed the image, no?
Well, that's the other thing, right?
Yeah.
Those images are purportedly immutable if they're on IPFS. They can't be taken down,
Oh, okay.
right?
And that was the big criticism. They're like, hey, yeah, it's immutable on at this point, but you just go a little downstream or just kind of around the fence and change it here. It thinks it's the
Will
same.
IPFS last forever?
Yeah,
Right?
exactly.
I mean, and that's asking that question is very similar for a blockchain too, right? Will there be off into the distant future enough incentive for people to keep running nodes so that we can access this information, right? On Cardano, we trust that there will be IPFS. I think it's reasonable to trust that, but similar lack of guarantee in both cases.
Got it. Okay.
Mm-hmm.
Okay, that makes sense.
Okay, so right, there's this limitation of metadata, and that note should say only replaced sometimes. But number two is the more important one, right? We also we can't use it for anything in our validation code. Okay, you have a space bud with an IPFS URL. What can I do with it? What can I write a contract that lets me do something with that metadata? I can easily write a validator that gives some privileges to holders of a specific policy ID. So any historic NFT series, I can write a contract that gives some perks to somebody who holds that policy ID. But I can't do any validation on what the image is or any of the rarity traits that people love to include. None of that stuff can be validated against.
Okay.
And when you say holds the policy ID, that means just having a specific token like this in my wallet? Or is it more like having a key to the contract address or something like that?
Yeah, but well, I think those two things are virtually synonymous. That's really interesting, right? Yeah, when I say holds the policy ID, I mean you have a wallet with a token with that policy ID, right?
Mm-hmm.
Now that you do, this can serve as the admin key to arbitrary functionality.
Oh, okay. Makes sense.
Ooh, typo.
Oh, I don't even see it.
Where is the typo?
How SIP68 work?
Ah. I'm going after it right now. Oh, I'm ready to type in some commands. Let's get to the step by
Guys,
step. I
yeah,
see it.
okay. We've done a lot. I mean, this is BBK, right? Everything's BBK. All right,
Yeah.
but let's go build it. What we're gonna do, we're gonna mint two tokens with the same policy ID. We're gonna give them almost the same name, except for these prefixes. That's just a standard for people to agree upon. There's nothing magic about the numbers 100 and 222, just like there's nothing magic about the number 721 in SIP 25. Okay. But the SIP suggests, hey, what if you put a 100 on the token that goes to some remote address and a 222 on the front of the token that goes to the user's wallet?
I love it. Okay. I know that I was just like, oh, I want to make some commands, but now all of a sudden this makes tremendous amount of sense
Yeah,
because
it does make a lot of
you know
sense.
what I'm saying? Okay, Harsha gets it. I'm getting it. We're on the same
And
page.
this is a big deal, right? Like the opaqueness of what's at the protocol level and what's just a standard is a really, really hard thing for a newcomer to wrap their head around.
Yeah.
Right. Am I doing this because I have to, or just because people agreed to? All right. You've got these three repos set up. You showed us Demeter. So we're going to use the transaction examples, Aiken, and the front end in that order.
Transaction examples. Create a wallet with Cardano CLI.
And you could do this, but you don't have to. Well, do you have a wallet yet in
I do
this
have a wallet.
instance?
1 second. So I have keys, so I should
And
have
actually,
wallet.
honestly, I'm looking closer. You actually don't need the wallet. All you need are the scripts. So if you go into transaction examples, module 203, and then SLT 2034 reference token pair. That's all we need is right there. And there's a script 000 create policy.
Okay.
This is where we left off last week, right? Was just running this script. And you can see that you already ran this script because you have test token as a subdirectory.
For this one.
Mm-hmm.
Okay.
And
Is
you've
it
got
like a hash or?
that's a well, yes, it is a hash, and that's what a policy ID is, right? So this is not, it's not a legible string, right? It's just a hash of our minting policy essentially. And that's what a transaction policy, or sorry, and that's what a token policy ID is. Okay, so that's going to be the policy ID that we use. You've already run this script with the token name test token, and we've got the policy ID. I think we're done with step 0.
Yes. So we have run this part. So step 1, reference token pair I can build the validator. Should I reference token pair? Let me quickly check if I have reference token pair.
That's the right spot. but we want to jump into PPBL 2024 Aiken examples. So from the command line, that's cd ... And then we'll cd into PPBL 2024 Aiken.
Oh man, come on, Harsh.
All right. And then what are we going to do there? Now let's go back to the instructions. Oh, yeah, you got it. Now we're going in, right? So the way Aiken projects work is you can collect a lot of different validators within the same project root. So the project root in this case is the Aiken examples directory that we're in. But the particular validator that we want to look at is this one, reference token pair.
Okay. Reference token pair.
So just on the command line, just type cd and then start typing ref like ref and press tab.
Yeah.
No, come on, no,
Try
Harsh,
it.
try it.
Stick to the keys.
Ah,
Fine,
time,
I'll
next
try
time.
it.
it's okay. You can be
I
you.
mean,
You can do you. We don't want to make you into a, but just try this. You might like it.
ref and then tab.
And then tab, yeah.
Yeah.
Did it
Okay,
work?
perfect.
Look at that. Look at that.
Okay, so now I'm in this guy, and let me see. So Aiken build. So what does that do? Aiken build.
What's to really see what it does, look at the plutus.json file and just delete that. That one right there. You can delete it.
Okay.
Yeah, just
Because
delete the whole file.
Aiken build, yeah, just the whole thing.
Oh, delete the whole file. Okay.
Yep. Because what Aiken build does is it writes this file.
Oh, I see. I see.
There it is.
Okay.
Now, by the way, covered earlier in the course, but worth remembering right here, there's a command called Aiken check. Try running that. Okay. This is a little bit like trying to run like npm run build. Okay. But it's even faster. And when I'm working on Aiken, I run Aiken check once every couple of minutes because I want to see those 2 zeros at the bottom. Summary, 0 errors, 0 warnings. It feels really good to see that, right? And by running this frequently, you spot errors as soon as you make them because you're definitely gonna. And Aiken is incredible in its error reporting. It's very helpful. It points you right to where you need to go. So we can mess up the code a little bit later. But for now, we can see Aiken check, good. There's no errors and no warnings in our code. Aiken build, we built it. Now we got this plutus.json file.
Okay, perfect.
Now, let's look at the source code for this for just a second. That's in the reference token pair.ak file. Okay. This is a validator. And as a spending validator, it has a datum. We can see the reference token datum type defined on line 12. And it has a redeemer, and we can see that data type defined on line 17. But does that datum look familiar?
Oh, yes.
New image URL, new
Okay,
description, and token name.
So
Image
we
URL
didn't
description.
enter the token name, so it automatically detected it in the front end, I remember.
Oh, okay. Now we're getting into it. This is perfect. So the datum is the on-chain part, right? Lines 12 through 15, we see what's actually in the UTXO. You just have an image URL and a description, right? That's the store, right? That's the stored data. It's on the blockchain. The redeemer is, as users, this redeemer is our statement of intent going into this transaction. Hey, what do I intend to do with this transaction? Well, I would like to change the image URL to this new image URL. I'd like to change the description to this new description. And I'm me. I'm the holder of this token.
Oh, just because we signed with our wallet?
Well, now this redeemer, I may or may not be telling the truth. Let's go see how these things are used. Okay, so search this file for token name. You can press
Which
Command,
oh,
press
just
Command
here.
F, yep, and token underscore name.
Oh, here it is.
Mhm.
Well, underscore name, because there's a lot of tokens, but
Yeah.
okay, there are 4 of them.
Let's look for that down in the file. How are we using that token name?
Oh, I got it.
Line 29 is called destructuring. It's a scary word when you first hear it, but look at those curly brackets on line 29. What we're doing is we're taking a redeemer, which is defined on line 26, because that's an input to a validator. Okay. And on line 29, we are destructuring that redeemer into the 3 parts that we know it has. How do we know it has those 3 parts? Well, because we defined them on lines 18 through 20. And once you destructure a variable like redeemer in this way, now you have access to new image URL, new description, and token name. So token name comes from the redeemer. Past line 30, we don't care about that anymore. Now we're like, okay, great, we have token name. Let's use it in our logic. We use it on lines 35 and 36 to do what?
To add the token name to both the tokens, to the policy, uh, to the token. Yeah, add the token name to the token. Or
Try to read line 35 from left to right.
let token 100,
Which is an asset name.
which is the asset name, is equal to append byte array. That means we are adding, right? Like adding at the end, right?
Concatenating. Yeah, we're concatenating 2 strings.
Which is 100 and whatever the token name that we defined.
Yes. Now, so that means on line 20 in the redeemer, we're not expecting you to include the 222 that's at the start of your token name, right? Because on lines 35 and 36, we're going to say, okay, this redeemer says that the intent of this transaction is to add a new image URL, a new description for this token name. Okay. Well, for that token name, there's a 100 token and there's a 222 token, isn't there?
Yeah.
So now we say, okay, given this redeemer, these are our expected token names for the 100 and the 222 tokens. So now search for either of those. Search for TN100 or TN222. Okay. What does this say? This is line 70 through 74 is really one Boolean.
Let's do. So value dot quantity of, as in
I think you're exactly right to point to like, okay, value dot quantity of where could I learn more about this? Search for value in this doc and go all the way up to the top. You can press the down arrow, yeah, or go all the way to the top. And let's look for the first, even earlier than this.
oh, well, okay.
Where's value coming from? Oh, that's built into Aiken. And actually, can you handle one more tab? Let's go to Aiken Lang, the website. aikenlang.org. Or it's Aiken-Lang, sorry. Okay. And then go all the way to the bottom to the quick links and click on the standard library. Okay. And we're curious about transaction value, which yeah, you could search for it. That's great. Perfect. And it's that first one, right? Because that's what you're
sorry.
importing. Aiken, that's it. You're in the right spot.
Oh,
Yep. That's what you were importing, right? Aiken transaction value.
yeah.
Let's go check. And then what function were we particularly interested in?
We were interested in value dot asset name.
We had that one down below, but there was another one.
Oh,
And
right
by the
here.
way, okay, sorry. And
Quantity of.
quantity of, that's the one. And by the way, this is here for a reason too. Scroll up to where we're using asset name. Right? I didn't just on lines 30 something or yeah, 35, 36. The reason we don't have to type token.asset name is because we pulled in asset name specifically on line 4 in those curly brackets.
Oh, okay, okay.
We're also pulling in everything else from value, but if we want to use it, we'll have to use value dot and the thing. Now, if I wanted the shortcut for any other functions, I could make it like line 3 and pull in as many different things as I want. And can you kind of see that destructuring pattern happening right there as well?
Yes, yes, yeah.
Right. So quantity of, we're using it here, but if we go back to that documentation, we should probably be able to find quantity of on this page. Yeah. Okay, this is a function.
Quantity of given asset. So the number of
Right. So look, quantity of that's a different function, reduce. We just want to quantity of has this single line, right?
Oh.
What's the definition? It takes how many parameters
So policy ID and asset name and
value.
and value. Okay.
It takes a value, a policy ID, and an asset name, and it returns
Integer.
an int. So let's look at that quantity of call in our code again. Ooh. I see
So
3
reference
parameters.
token.
Yeah.
Reference token symbol and okay. So 1 second. So this is the value, policy ID, and asset name. So one of this, so this is the value, reference token output value. Asset name. So asset name is the same as symbol, or is this the asset name?
Policy ID. Yeah, TN100 is the asset name. And policy ID and currency symbol are synonymous. So
Okay.
we're just, I'm using both here just to help people see like, okay, currency symbol, policy ID, same thing.
Okay.
And remember, this is a Boolean statement on line 75 to 79. It's going to return true or false because what are we checking?
Oh, so this returns an integer and it checks if both the integers are equal, right?
It checks that the integer is exactly equal to 1. But the value where?
Yeah. So 1 second, I want to see quantity of, okay. Oh, so it's basically checking if there is exactly 1 token in the wallet.
Not in the wallet. This is important.
Oh, this is 100. So in the contract.
Read line 76.
76
the value
reference token output.
Where's that defined? Search for
Reference,
that.
I'm gonna reference. Reference token out. Is there anywhere else?
Oh, there's an extra T that's stifling your search.
Oh,
There we go. Okay, so once we have the reference token output, we're curious about its datum and about its value. But we define it on line 41. Now
so it is.
this expect thing is unique to Aiken. And it's kind of a really nice little trick. We're basically saying, hey, we think there's going to be this variable. And if there is, keep going. But if there's not, then this contract, like this code will fail, right? We don't have that variable. So we expect to find this variable that we're going to call reference token output. Where are we looking for it? Line 42. In a list, we should probably
And
find
we
out
are
where
filtering
list
the
is.
list for
Right.
something.
Right. We're
So
filtering all the outputs of this transaction. And we want the one where the
output
address on that
address.
output.
Oh, okay. Output address equal to reference token input dot output dot address.
And so now basically what that's saying is that, well, this reference token has to come from the same address that it's output back to. Okay. And you can see on
Oh, I
line
see.
38 where we're getting a similar expect the input. Look at all the inputs, find the input with an output reference equal to UTXO ref. What's UTXO ref?
Reference UTXO.
It's just it's this transaction. It's the one that we're currently in the context of, right? So this validator code can only be run inside of a transaction. So the UTXO ref says, okay, in this transaction, get the output reference of the input. Okay, good. Those are all of our inputs. Now look for a particular one, or I'm sorry, right? Input.output reference. We're saying get the input that's coming from this contract itself, right? There were several different inputs, but we're curious. This validator is curious about the one that's coming from the script that it controls. The addresses have to be the same. So this validator will fail if that reference token is like if somebody tries to send that reference token anywhere other than back to the reference validator. But that's just the UTXO part. Then we look at the token in that UTXO to make sure that it matches something. What does it need to match?
It needs to match the output address. No.
What gives me the ability to change the datum and change one of those images in the gallery that we
Minting, having pulse. How did you phrase it? Having ownership of the policy ID or owning the policy?
Yes, I need to have a token with that policy ID in my wallet, and not just any token with that policy ID. I need the one with the name that matches the 100 token I'm trying to change.
Okay, so it's basically checking for this part.
Remember, that comes from the redeemer. Okay, so I walk into this validator. I treat the validator like it's a bodega, right? I walk into the validator and I say, I would like to change the datum associated with this token.
Correct.
Well, show me your ID. Show me your 222 token. You got it?
Correct.
Okay, fine. You
Yeah.
can change the datum. Now, how that exactly happens doesn't happen right here. Up here, we say, okay, look, so-and-so walked into our validator and they said they want to change this token. So let's assume that there's going to be a 100 token and a 222 token with that name on it.
Correct.
We set those variables. Then down below, we use those variables.
Yeah.
Right. Lines 47 through 61, we check that both the input and the output have the 222 token in them.
Correct. Okay.
All right. Does the person with their wallet, this is where we check their ID. Hey, are they walking in with the right 222 token? Do they have exactly one of those in the wallet? That's line 51.
Hmm.
And on line 59, oh, and we want to make sure they leave with it too. Right? Make sure don't let them leave without their 222 token.
Oh, okay. So, okay, got it.
This validator would fail if you tried to send your 222 to somebody else while also changing the datum.
Hmm. So, don't let them leave without the token, as in first we are sending the token to the contract and the contract is sending it back. Is that what's happening?
The transaction is doing the sending. Yeah, so the transaction spends the UTXO that has the 222 token in it, and then it creates a new UTXO that sends it back to your wallet.
Okay, got it. Okay.
Let's skip over 64 and 65 for just a second. We're going to come back to that. Let's stay on lines 70 through 79 now. Okay. So then we say, okay, well, first of all, token name 100 was derived from the same token name as TN22, right?
Mhm.
Or TN222. All right, so we know those both came from the same place. We know that the 222 tokens are already included in this transaction. So now we can say, okay, now the same 100 token has to be spent from this validator and sent back to it. That's all lines 70 and 70 through 79 are doing, right? Look at the input, make sure there's a reference token with the expected token name. Look at the output for the same.
Yeah. So this is the only part that's changing. Okay.
So that's all like the access control part.
Mhm.
But there's also some optional logic in here that I think it's best to see this as just an example. I'm not sure. I haven't really thought all the way to like whether or not this has a real world utility. Okay, but all we're doing here on line 68 and 69 is we're saying only validate if the image URL that we're going to send out is the same as the image URL that they stated. I'm looking at, sorry, 68.
Oh, okay.
Right. So new image URL, remember that comes from the redeemer,
Mhm.
right?
New image. Okay. This
And
one.
we're checking that that new image URL matches the image URL in reference token datum. Now, where does reference token datum come from? That comes from line 65. Okay, and this is the datum on the output.
Hmm.
And there's a key distinction to make here as well. If you scroll back up to the top of this validator, right? Any spending validator is going to have a datum on it. we can see it on line 25. But that's the incoming datum, okay? When we define that datum on line 25, what we're getting access to is the datum that was on chain before we tried to build this transaction,
Mhm.
okay? But that's not what we're interested in. We're not interested in looking back at what the datum used to be. What we're validating for is what we are changing the datum into. And that's why we need lines 65 and 60, or 64 and 65. We say, okay, get the inline datum from the output, call it reference token datum, and we're going to assume that it's of type reference token datum the way we've defined it above. That's all the way up. Okay, so on line 12, we defined reference token datum.
Yeah.
And on line 65, we're saying, hey, this datum, it's gonna be of this type. Line 65, right? Hey, expect this variable reference token datum, colon, to be of this type reference token datum. And get the value from this ref output datum that we expected in the line above. If all of that works, if those two expect statements pass, now go to line 68 and use that reference token datum. Okay, well, if indeed line 65 worked, then this reference token datum is going to have an image URL. And that image URL has to match the stated intent from the redeemer.
Mm.
How's this feeling? I know we went deep into this, but what do you think?
I I think I understand it slightly better. Um, yeah, at least I understood like the structure, how like the uh how this icon script is structured better. Yeah.
All right, so there's
So
one.
I have a small question here. So in the previous datum exists in some transaction, right?
Yes, the datum, the previous datum in the case of like the last transaction we looked at where you updated it, the previous datum was that default Gimbalabs G, and the
Correct.
description just said some G.
Okay. So when for the with the new policy ID, sorry, not the new policy ID. So now the policy ID just references the new transaction, or does it reference both the old and the new? Because we only
Okay.
changed URL
Yeah.
and description.
Right. So anytime this validator is invoked, it's going to be on a transaction that really only has visibility to the current existing UTXO. Meaning that after you mint this token, if you update it any number of times, one or more, right? The current state is only what's in the most recent UTXO, right? The unspent UTXO at the end of the blockchain.
Okay. So in that case, so the unspent UTXO should also have the name of the token. Is this the name of the token that's on the new UTXO?
It will be, and that's exactly right. That's why when we say reference token input on line 71, for example, that's exactly what we mean. Hey, the thing we spend has to have this token in it. We're going to spend this UTXO, this reference token input, and it's got to have this TN100 in it.
Mm.
Also, the new UTXO we create, the output, has to have that token in it too. That's what lines 75 through 79 says.
Makes sense.
So we're checking both. Yeah, the input, which is after this transaction will now be irrelevant, and the output, which would be the input of the next transaction.
Makes sense. So by the end of the day, it feels like we're only working on 100. That means we're only working on the token inside the validator. Does it also, so how does like the TN222 change if we are specifically doing this to TN100?
Okay, good. So the token name itself is not going to change, right?
Mm-hmm.
That token's already been minted. I've got one in my wallet and we've got one at the validator address. But your question is really important, and this does feel a little bit like magic here, but there's some logic behind it. Remember back on lines 34, 35 when we defined these names, or 35, 36, sorry.
Mm-hmm.
We said, okay, whatever the redeemer says, the redeemer is going to specify a token name, right?
Mm-hmm.
Whatever that name is, use it to create TN100 and TN222.
Mm-hmm.
Okay. So first of all, the redeemer has to match your token in the first place. And when we look at the mesh code, we will look at that. Right.
Uh-huh.
But we say, okay, yeah. Given that the redeemer says this token name, we expect there to be this TN100 and this TN222.
Mm-hmm.
Okay. And then on lines 47 through 60, we say, hey, this transaction can only work if that 222 token is there.
Correct.
And then lines 70 through whatever say, well, it can also only work if that 100 token is there.
Mm-hmm. Yeah.
And because of lines 34 and 35, we know that those token names have an equivalency. They both have a prefix and then the same token name.
Mm-hmm.
Right? So put it all together, and you have to have a particular 222 token to change the datum associated with the 100 token.
Correct. So we are checking if we have this token, and we have appended the names, and we are saying we are changing the datum associated with the 100 token. And does that mean it automatically changes the datum associated with the 222 token?
Okay. So a lot of what we've been talking about is like validator logic so far. And the validator logic is enforced by the blockchain.
Mm-hmm.
However, the relationship between the 222 and the 100 token, that's not enforced by the blockchain. That's a standard.
Oh, so that's the 68. Okay.
Yes. Okay. So we can write this contract as a way of implementing, in this case, only a part of CIP68. We're not implementing all of CIP68. And actually, CIP68 doesn't say that that the 100 token has to be at a validator address. It doesn't have to be. This is just showing one way that we could build a validator based on that standard.
Oh, I see.
Oh, okay. CIP68 suggests the 222 and the 100 prefixes be used this way. All right, well, here's a validator that takes that suggestion and uses it in this code.
Okay. Got it. So if the reference token, the 222 token is not in a validator, that means neither of those tokens can be changed anymore?
No, so actually, remember the 222 token is the one that goes in your wallet,
Mm-hmm.
and the 100 token is just the token that goes somewhere else.
Correct.
In this example, we're assuming that the somewhere else is a validator address,
Uh-huh.
but it doesn't have to be. It could just be somebody's wallet address. Datum can be stored in any UTXO, even if it's not at a validator.
But if I had to change the datum, it has to be in a validator, no?
Even that, no. What this validator is achieving is it's setting non-custodial rules for
Mhm.
how datum can be changed.
Oh, I see.
Okay. We could put your 100 token in just some random wallet address, and then the owner of that wallet would be able to change the datum, or they'd be able to erase it. Or they could just send your 100 token somewhere else. That doesn't seem very dependable. You could also make an unspendable address. Okay.
Mm.
And you can send some 100 tokens there, which would essentially make the datum immutable, right? Just like we said that SIP25 data can't be changed, metadata
Mhm.
can't be changed. You could achieve the same thing here by putting the 100 token at an unspendable address.
Got it. Got it. Okay. Okay.
Now that would still, you might say, well, what's the point then? Why would I just use SIP25? Well, what's cool about this is even if that datum is at an unspendable address, you can still read the datum in another validator that might have some other purpose that depends on that datum.
Oh, I see. I see. Yeah,
And
that makes
that
sense.
leads us to some pretty interesting use cases.
That makes
Okay,
sense.
so we jumped into this code because we were on step 2, which was called applied parameter, and nothing makes me happier than staying in it for as long as we did. But now where's the parameter? The reason I was showing you all that code is so we could understand what parameter we are applying. Okay,
Mhm.
so go back to the code one more time. And up on line, it'll be like 20 or so, 23. We open up our validator right here, and often those parentheses on line 23 will be empty. It's fine just to write a validator with datum, redeemer, and context and no other properties. But we can also add all parameters we want to inside those parentheses. And that's exactly what's happening right here.
So when you say parentheses, are you talking about these or these
Yes.
guys?
Yeah,
Okay.
line only on 23.
Okay. Okay.
And so what is the parameter? Oh, it's a reference token symbol. This is a really, really important idea about how any Plutus works, whether we're writing it from Aiken, Plutus TX, or somewhere else. What we want to be able to do is write the validation logic a single time, but be able to reuse it in many different contexts. And that's what we have right here. I don't have to change anything below line 23 because all of that code already works. But I want to be able to use it for a lot of different tokens. Line 23 allows us to do that. This says, okay, yeah, bring your own policy ID. And you can apply this validator logic to whatever policy ID you want.
Mhm.
And I think that's where we're going to have to pick up tomorrow. So tomorrow, now that we've had this overview, we can look at how to pull any parameter we want to into our compiled code. And then we'll turn it into a Plutus file. We'll deploy it on chain so that we can use it. And then we'll see how to use a different instance of this by looking at the mesh side. But mesh is going to show us a lot of stuff that's really helpful. If you understand what we're looking at here in the validator, now the next question is, okay, what does the transaction look that look like that supports this validator? How you feeling?
I'm feeling pretty good, actually.
Good.
Yeah, that was something I was able to sort of follow a little bit. I got a call that I had to take and got me a little bit off the train, but these deep dives, especially they're recorded and they're out there live. I will try to get back in and as we go through the lesson, and I'm looking forward to tomorrow. That'll be good.
Awesome.
Yeah.
All right, pick it up right here tomorrow. Thanks, guys. Really feels
Thank
like
you,
a
James.
breakthrough.
Yeah, thank you. This was
pleasure.
great. Yeah.
Yeah, this is really, really
I mean,
awesome,
I don't know
actually.
how good the video will be, but like at least I'm learning.
Yeah.
It feels really good. Yeah, we're breaking new ground. Wherever we go with it, this is how we discover what we're gonna do next. I'm so here for it. I love it.
Amen.
All right. Till
All right.
tomorrow, guys. Have a
All
good day.
right. See you.
Bye.